Hey, welcome to a demo of how DBtune platform works. What is DBtune? DBtune is a PostgreSQL server parameter optimization platform that automatically tunes your Postgres instance to deliver optimal performance. By using machine learning to analyze your workload and recommend configuration settings, DBtune can help you improve query response times, increase throughput, and reduce your infrastructure spend by increasing the efficiency of your server, all without requiring any manual intervention or downtime. Now that we know what DBtune is, let's head over to app.dbtune.com and create an account. You can also find the link in the video description. You can sign up using your email and password, or simply use Google Sign In. For this demo, we'll go with Google Sign In. Once signed in, let's create our first database. Give it a name that helps you remember what you're optimizing. In my case, I'll name it AuctionMark-Red Hat, since it's a database hosted on a Red Hat virtual machine running the AuctionMark workload in the background. AuctionMark is an OLTP workload that simulates the activities found in a well-known auction site. It can be found online in the BenchBase benchmarking suite, and it allows evaluating in a more complex and realistic setting than running simplistic pgbench workloads. If you're just experimenting with DBtune and don't want to test on a production system, check out our synthetic workload guide, which explains how to spin off a synthetic benchmark to tune with DBtune, as we are showing in this demo. It's super simple to use, and the link is in the video description. Just keep in mind, DBtune needs a workload to optimize, so running it on an idle database won't produce any meaningful results. Next, we'll choose whether the database is self-managed or hosted through a managed service like AWS Aurora. We currently support Community Postgres, EDBE and AWS Aurora. However, this page is updated regularly as we add new integrations and support more Postgres flavors over time, so keep an eye out for upcoming integrations. For this example, I'll select Self-Managed Postgres and click to create the database. Once the database is created, we're automatically redirected to the agent setup page. Here, you'll find instructions on how to connect the DBtune agent to your system. We will skip the first part, as we have already created a user for this demo. The only extension DBtune requires to operate is pgstat statements, which has minimal overhead for your Postgres instance. We provide the agent as a precompiled binary or as a Docker image. If needed, you can even build your own adapter to customize how DBtune collects metrics and modifies configuration settings for your Postgres instance. In this case, I'll connect the Docker agent to the Red Hat VM and begin monitoring the Postgres instance. Now, to run the agent, we can run a simple Docker command. Before that, let's see the containers we are running with the Docker stats command. We have two containers running, the workload container and the Postgres container that is restricted to 12 gigabytes of memory. Let's create now our DBtune YAML file and copy-paste the template YAML content we have in the platform. After doing this, we can change only one thing, the Postgres connection URL. Let me paste one I have already prepared. Now to run the agent, we can run a simple Docker command. Let's paste the command from the dashboard and run the agent. After pasting the command, we run docker ps to see that the agent is running, and then docker logs, and we see that agent connected without any errors. Everything seems to be running correctly. So let's head back to the dashboard. As soon as the agent is up and running, DBtune will start collecting data from your database. Let's switch over to the dashboard tab to take a look. Here, you'll see a real-time overview of your database metrics, such as average query runtime, transactions per second, CPU usage, RAM consumption, and more. Once you're ready to start tuning your database, head to the Tuning tab. There are a few key settings to be aware of here. First, the operation type. DBtune supports two modes, Restart and Reload. Restart mode applies tuning changes that require restarting the database, like shared buffers, while Reload mode applies changes that don't require downtime. For most cases, Reload is the recommended and safer choice. You can refer to our documentation at docs.dbtune.com to see which parameters are modified in both those scenarios. Next, we have tuning objectives. Currently, DBtune supports three objectives: average query runtime and average query runtime 99%, which are minimized, and transactions per second, which is maximized. By default, average query runtime is selected, but you can change the objective based on your specific goals. Finally, there's the tuning iteration time, which defines how long each configuration will run before evaluating its impact. The default is 5 minutes, which works well for transactional workloads. But you can increase this number if you have a mixed workload, for example. In our example, we'll stick with the default settings and start a tuning session. Since this can take up to 3 hours, let's fast forward and look at a previously completed session. Now let's dive into a tuning session. In the performance summary, you'll see all the configurations DBtune tested, along with their corresponding performance metrics. The very first one is labeled baseline. That's the original configuration, before any tuning began. Each subsequent bar represents a configuration DBtune tried. The best performing one is highlighted in green. You can click on any configuration to view the specific parameters used and how the system behaved during that time. By hovering over the tuning summary, you can also see how each configuration compares to the baseline, including metadata like the tuning mode. In our case, it was a server reload-only session. DBtune decided to turn off parallelism by setting max worker processes to 0, as well as lowering the random page cost. When the parallelism is not needed, it causes an unnecessary overhead, and for the auction mark benchmark, lowering the random page cost makes better use of the database indices. When a tuning session ends, the best configuration is applied to your system, so you will continue to run with the best possible performance. That wraps up our short demo of DBtune. To learn more, visit www.dbtune.com or sign up and start optimizing your Postgres databases today.